All right. So the sun, the earth, the moon, and then it says mean earth-moon distance, 3.80 times 10 to the fifth kilometers. Here they've got 3.84 times 10 to the fifth. I'm just going to go with that because that's probably a little more accurate, right? But I'd probably use 3.80 times 10 to the, and then this is 10 to the fifth kilometers, so isn't it 10 to the eighth meters? Yeah, 10 to the fifth kilometers is 10 to the eighth meters. And then we got to square that. Okay. So now we can figure out the force of gravity, right? 6.67 E minus 11 times 5.97 E to the 24 times 7.36 E to the 22 divided by 3.84 E to the 8th squared. And the force is a lot, right? The force is 1.9875 times 10 to the 20th newtons, right? But keep in mind that the Earth is kind of big, right? So the acceleration is actually not going to be all that big. So the first question was, what's the force of gravity between the Earth and the Moon? They have 2.03. I'll bet that digit there made the difference between, but it's very close, right? Physics! Okay, then it says, what acceleration does the Moon undergo? Use F equals ma. Well, here's the Moon's mass, right? Okay, so if that's the force, 1.98 times 10 to the 20th, right? Equals 7.36 E22 times a. So we just divide this by the mass, right? So divided by 7.36 E22. And I get that the Moon accelerates at about 2.7 times 10 to the minus third meters per second squared. So not really very fast, right? 0.0. I think it's 0027, isn't that what it is? My calculator is like locked in scientific notation, but isn't that right? Right. So there's the second answer, and the answer I have on here is 2.8. So again, there's a slightly different, right? Then it says, what is the period of motion? Use a centripetal acceleration equation. So which one would give us a period? Is it the one with the period in it? Yes, right? So the proper equation to use is the one that you can use, right? So to figure out the period, I'm going to say that the acceleration is 4 pi squared r. Right? To solve for the period is going to be 4 pi squared r over a. And then what do I do next to get the period by itself? I square root it, which makes this kind of cool. It becomes the square root of 4 pi squared r over a. Well, can't you pull out the 4 pi squared and make it 2 pi outside? Can't you? Yeah, that's a radical concept. Right? But now, yeah, we can do that, right? So the period is that. So that's going to equal 2 pi square root of, and the radius is 3.84 E8, right? And then A is 2.7. It's like 7.00457 times 10 to the minus 3, right? So I'm going to go 2 times pi times the square root of 3.84 E8 divided by the answer I just got. I get 2.369 times 10 to the 6th seconds. How many days is that? Do they give the answer in days? So 2.3, I get like 2.4. Here it says 2.3, right? How would you convert that to days? Well, I divide by 24 and divide by 3600. Yeah? So I would just divide this by 24 times 3600. So divided by 24 divided by 3600 It's about 27 days, 27.4 days. Yeah. So a lunar cycle is not exactly a month, but it's close to a month, right? Especially if it's February. Not so much, other months, but there it is. Yeah, that's a pretty hard one. How about number 3? Are we okay on number 3? Is 3 okay? So I guess this is something we need. This is the Earth-Moon distance. Need to add that. Oh, dang it. I saw a ball rolling by. I was going to steal it, but